Good evening, everyone. Today I'll be talking about PSpice and basic logical gates. This presentation will give you an understanding of the logic gates and how we use PSpice, a powerful circuit simulation tool, to analyze the behavior. Let's dive in. Now let's start with the introduction to PSpice. What is PSpice? It is a simulation software used to design and implement electronic circuits virtually. It supports both analog and digital components, making it a versatile tool for students and professionals. Using PSpice for logic gates allows us to simulate circuits without physically building them. This saves time and resources. Now let's look at logic gates. Logic gates are the building blocks of all digital circuits. There are several types of gates including AND, OR, NOT, NAND, NOR, XOR, and XNOR. Each gate performs a specific logical operation. For example, an AND gate outputs 1 only when its inputs are 1. Logic gates are widely used in computing, data processing, and control systems. PSpices includes digital components. Adding gates to a circuit are simple. You drag and drop the components, configure their input and output, and connect them. This user-friendly interface makes PSpice a great tool for beginners and experts alike. Now let's take the first example of simulating an AND gate in PSpice. An AND gate produces an output of 1 only when both outputs are 1. To test this, we set up a circuit in PSpice with 2 inputs and 1 output. By running the simulation, we can verify the truth table of the AND gate and ensure the circuit behaves as expected. Second, let's simulate an OR gate. An OR gate outputs 1 if at least one of its input is 1. Similar to the AND gate, we set up the OR gate in PSpice, configure the inputs, and observe the outputs. The result confirms the OR gate's truth table, making it easy to verify the operation. Next, the third basic AND gate, the NOT gate. It is also called the inverter. It takes a single input and produces the opposite value as the output. If the input is 1, the output is 0, and if the input is 0, the output is 1. In PSpice, we can simulate the NOT gate by connecting a single input and a single output. This allows us to verify the functionality and behavior under different input conditions. The NOT gate is crucial in creating more complex logic gates as it helps implement logic negation and complement operations. Now let's look at combining logic gates. We can combine multiple gates to create more complex logic functions. For example, let's design a circuit for the function given in the truth table. The function is first reduced by using K-map. It can also be reduced using Boolean algebra. Using AND, OR, and NOT gates in PSpice, we connect the inputs and outputs to form this logic. The simulation helps us validate the design and check if it matches the truth table which we produced. Now let's look at timing diagrams for digital circuits. They are used to analyze how signals change over time. In PSpice, we can generate timing diagrams to understand the behavior and digital circuits, including delays or glitches. For example, simulating a NAND gate allows us to see how the output responds to changes in the inputs. While working with PSpice, we might encounter some common errors. These include incorrect pin configuration, missing power supplies, or choosing the wrong simulation types. To avoid these, double-click connections and ensure the simulation parameters are set correctly. If the error occurs, PSpice provides helpful messages to troubleshoot. PSpice simulations of logic gates are widely used in digital design applications. These include microcontrollers, FPGA designs, and signal processing. It helps in troubleshooting digital circuits and identifying potential issues early on in the design process. To wrap up, PSpice is a powerful tool for simulating and learning about logic gates. By using PSpice, we can understand and verify the behavior of digital circuits before physically building them. I encourage you to explore more complex circuits such as flip-flops and counters as your next step. Thank you.